Students, welcome to PhD Jobs and Admission. This is Gauri. So in this video, I am going to teach you about research methodology subject of PhD entrance test at Anna University. So in this session, I am going to teach you about skewness and kurtosis in research by using MCQs. So skewness and kurtosis, both of these concepts are relevant to statistical methods that we use in research, and both of these concepts are really very important in terms of statistical processes. Okay, and that's why on these two topics you will be getting more MCQs in the PhD entrance test at Anna University. So I have included all the points in this video. That's why you can clear all your doubts in this video. But still, if you have any doubts, you can ask me in the comment box after viewing this session. Okay, so students, before starting this session, I want to tell you that Global Online team provides you complete course on research methodology subject, because there is a PhD entrance test at Anna University on 7th May, and that's why if you want to qualify the PhD entrance test, then obviously you need to score more marks in research methodology, because there you will be getting 25% MCQs on research methodology itself. And that's why by using this course, all of you can qualify PhD entrance test by scoring more marks in research methodology subject. So in this course, we provide you full syllabus video lectures under which theories and MCQs both are available. We provide you full syllabus notes and mock tests. We provide you more than 1500 MCQs revision PDF, and all these study materials are available in both the languages, Hindi and English. Okay, so students, basically we have 10 mock tests like this, and each mock test contains 40 MCQs, and that's why overall you can solve 400 MCQs in these mock tests. By the use of this revision PDF, you can revise all your topics in a single PDF, and you will be getting 80% MCQs from this PDF only out of 100% MCQs in research methodology subject of PhD entrance test. Okay, so students, if you want to buy this course, then you can either download the Global Online app from the Play Store. For that, I have given the link in the description box of this video, or else you can contact me through these WhatsApp numbers. And the course fees are only 699 rupees, which are really very less. And in such low fees, Global Online team provides you step-by-step guidance at each and every stage of your PhD admission at Anna University. And as well, Global Online team provides you 100% passing guarantee, that you can guaranteed qualify the PhD entrance test over here. Okay, so students, let us start with our today's session now. What is the skewness of a normal distribution? Okay, so students, the meaning of skewness means asymmetry. Okay, asymmetry, and normal distribution means it has a symmetrical data distribution. Symmetrical data distribution means whenever you draw the graph, and whenever you plot different data distributions over here, then your plot will be like this. And that's why whenever you make the two halves of this curve, then the left and right side of the two halves of the curve will be equal, and it means that it is actually normally distributed data, and that's why it has a proper symmetry. And asymmetry means both of these sides are not equal, and that's why skewness of a normal distribution, obviously it would be 0, because there is no asymmetry, there is only asymmetry. That's why your correct answer should be 0. Okay, 0. Now next is, what is the formula for measuring skewness in a data set? So whenever we want to measure the skewness in a data set, then there is a proper formula for that, and we need to answer that formula, which is the formula from these options. So whether it is mean minus median, whether it is mode minus median, whether it is 3 in bracket mean minus median upon standard deviation, or whether it is mean minus mode upon standard deviation. Okay, so students, the common measure of skewness is the Pearson's movement coefficient of skewness. So the measure of skewness is called as Pearson's movement coefficient of skewness, and the formula is 3 in bracket mean minus median upon standard deviation. Okay, and that's why your correct answer should be 3. That is 3 under bracket mean minus median upon standard deviation. Okay. Now third is, if a variable has 3 values minus k, 0 and 3k with corresponding frequencies as 3k, 2k and k respectively, then the value of coefficient of skewness b1 or beta 1 is what? So here they have asked you to calculate the value of coefficient of skewness beta 1. So I mean to say, they have asked you to calculate this value, Pearson's movement coefficient, okay, which is actually denoted by beta 1, and they have given you certain data, and the data is, there are 3 variables, okay, and the values of those variables are minus k, 0 and 3k, and their corresponding frequencies are given. So for minus k value, the frequency is 3k, for 0 the frequency is 2k, and for 3k the frequency is k. So now students, now let us first of all make a proper table of this. So first of all, x is your particular value of a data set, then f its frequency, then fx would be multiplication of f with x, then x minus x bar means data set value minus its mean. So x bar means the mean of the whole data set, okay. Then again x minus x bar bracket square, then f into x minus x bar bracket square, okay. Then here I'll write x minus x bar bracket cube, and the last one will be f into x minus x bar bracket cube. So actually we need to calculate all these points or values first of all, because all of these points are actually we need it for our further calculation. So first of all, let us write down the values of x, which is minus k, 0, 3k, and their corresponding frequencies will be minus 3k, 2k and k. And now do the multiplication of f with x, so it will become, sorry, this is actually 3k, right? Yeah, 3k, this is 3k, so it will become minus 3k square, 0, and it will 3k square, okay. And do the total of this at the end. So here the total of this will be 6k, the total of this will be 0, the total of so let us do the total of this frequency. So it will be 6k, okay, and the frequency the total of this fx will be 0, okay. Fine. So we actually don't need to total of this, okay. So now first of all, let us find out the mean of the whole data set. So whenever we need to find out the mean of the whole data set, then the formula is mean is equal to x bar is equal to summation of fx upon capital N. So now fx will be this fx, okay, and its summation means the summation of all these values, and capital N means total number of observations, which are 3, because there are 3 values of the variable, right? So it will be 0 upon 3 will be 0, and that's why the mean value will be 0. Now let us find out the mode. Mode means the value which occurred frequently in the whole data set, or the value which has the highest frequency in the whole data set. So here you can see over here that 3k is the highest frequency, right? And this is the frequency of minus k, okay, and that's why your mode will be minus k, okay. Now we need to find out the another values, which are mu2, mu3, okay. Here mu2 and mu3, okay, both of these are called as the central actually coefficients, and these are really very important to all of us, because these concepts are there in the skewness actually, and you don't need to go in depth within it, you need only understand the formula behind it. So the value of mean, that is 0, is actually your mu1, okay, which is mean here, and after that you need to find out the value of mu2 and mu3, which are actually the movement of coefficient, like that, okay. Basically they are called as movement of coefficient, so don't go depth to it. So let us find out now the values of x minus x bar. So it will be minus k, here it will be 0, it will be 3k and their total will be 2k. Now let us do x minus x bar bracket square, then it will be k square 0 and 9k square and their summation will be 10k square. Now do f into x minus x bar bracket square, then it will be k square 3k cube, then 0, then 9k cube and then 12k cube. Now f in bracket x minus x bar bracket first of all find out the value of x minus x bar bracket cube. So the value will be minus k raised to 3, then 0, then 27k cube and then their total will be 26k cube. And at the last find the value of f into x minus x bar bracket cube. Okay, so over here the values will be minus 3k raised to 4, then 0 will be as it is 0, then 27k raised to 4 and their total will be 24k raised to 4. Okay, now let us find out the value of mu2. Okay, so I will write the other values over here. Okay, so the value of mu2 will be summation of f in bracket x minus x bar bracket square upon capital N. Okay, so now here you need the other values. So now let us find out what is summation of x minus x bar bracket square. So yeah, so it is what, 12k cube. Okay, this is 12k cube and your capital N will be 6k in this situation. So here 6k. Okay, because you need over here the summation of f. Okay, not the summation of basically the all the numbers like capital N. So you need over here 12k cube upon 6k. So why we took here 6k? Because there is summation of f. Okay, there is summation of f. There is not only capital N. All of you understood, and that's why the mu2 value will be 2k square. Okay, now let us find out the value of mu3, which equal to summation of f under bracket x minus x cube bracket cube upon capital N. So now let us see over here what is the value of summation of f into bracket x minus x bar bracket cube. So which is 24k raised to 4. Now all of you understood, and that's why it will become 24k raised to 4 upon 6k, as it is 6k, so it will become 4k cube. Okay, so now whenever you need to find out the coefficient of skewness, that is beta 1, so its formula is mu3 square upon mu2 cube. So now here you have found out the values of mu3 and mu2. Now substitute these values in this formula, then at the end you get the values 16k raised to 6 upon 8k raised to 6, which equal to 2. So that's why your correct answer to this question should be 2. Okay, all of you understood. I know that this is little bit difficult to understand, but whenever you solve such kind of questions at least 2 to 3 times, then you will understand exactly what they are going to say and how it can be solved. Okay, now let us go to the next question. In a negatively skewed distribution, so whenever there is a negatively skewed distribution, then what will happen? Okay, so students, whenever there is skewness and which is negative, then in that situation mean is smaller than median. So mean value is basically smaller than median. Okay, and distribution has large tail of small values. So there are small values of the data, but they will be having a large tail. All of you getting? And that's why whenever there is negatively skewed distribution, then in that situation mode is greater than median, which is greater than mean, and that's why your correct answer would be 2, because here mode is greater than median and median is greater than mean. Okay, now next is if the distribution is negatively skewed, then so again they have asked you the similar question, but the options are different. Mean is more than the mode, median is at right to the mode, mean is less than the mode, mean is at right to the median. So as I have told earlier in the question 4 that in this situation basically mean is smaller than median and median is smaller than mode, and that's why your correct answer would be 3, because ultimately your mean value will be less than mode in the negatively skewed distribution. Okay, the first 4 raw movements of distribution are 2. Okay, 136, 320 and 40,000. The coefficient of skewness is. Now again here in this question they have asked you to calculate the coefficient of skewness, but they have given you 4 raw movements of distribution. So actually there we have seen mu1, mu2, mu3, mu4, right, in the last previous question. So in that question they are called as basically the central movements or the central coefficient movements, but here they have given you the values of raw movements. So by the values of raw movements, now we need to calculate the values of central movements. So first of all write the values of raw movements. Now let us assume mu1 slash is equal to 2, then mu2 slash is equal to 136, mu3 slash is equal to 320 and mu4 slash is equal to 40,000. So now let us find out the values of central movements. Now mu1 is your first central movement, so mu1 is equal to mu slash 1 which is equal to 2. Okay, the formula is actually same. Okay, now whenever you need to calculate the value of mu2, then for that the formula is mu2 slash minus mu1 slash bracket square, and that's why your correct value for the similar which is equal to 132. Now let us find out the value of mu3 which is equal to mu3 slash minus 3 cross mu2 slash mu1 slash plus 2 in bracket mu1 slash bracket cube. Okay, and whenever you calculate all these things, whenever you substitute the values of other materials like mu3 slash, mu2 slash, mu1 slash, then you will finally get the value which is equivalent to minus 480. Okay, now let us find out the values of mu4 which is equal to mu4 slash minus 4 cross mu1 slash cross mu3 slash plus 6 cross mu2 slash in bracket mu1 slash bracket square minus 3 mu1 slash raised to 4. Okay, then again substitute the values of these materials, then finally you will get the value of mu4 which is equivalent to 40656, and according to the formula that I have told you earlier in this video, the coefficient of skewness which is denoted by beta 1 is equal to mu3 square upon mu2 cube. Okay, and that's why your correct value for the same which equal to minus 480 bracket square upon 132 cube, and that's why your correct answer for this question should be 4, because minus 480 bracket square upon 132 cube. So I can give you one trick for this. So here they have given you a raw movement for fourth raw movement, so which is 40,000. So when you don't calculate the central movement for this value, then it will be okay, because you don't need that value in your final answer, because within the beta 1 formula there is no mu4, right? You need to calculate only mu3 and mu2, so it is sufficient. So you don't waste time in calculating the mu4. Okay, I have calculated it because I want to tell you the formula. Okay, but it is not necessary, so take into consideration these things. Now for a frequency distribution of a variable x, mean is equal to 32 and median is 30. So now the distribution is, now there is a frequency distribution of a variable x, and they have given you the values of mean which is 32 and median is 30. So now what kind of distribution would it be? Whether it would be positively skewed distribution or negatively skewed distribution or mesokurtic or platykurtic. Okay, so students, now let us see find out first of all the value of mode. As we have seen earlier in the previous video of central tendency, measures of central tendency, the relationship between mean, mode and median is that mode is equal to 3 cross median minus 2 mean, right? So here they have given you the values of median and mean. Now substitute these values in this, then after that you will get the value of mode, which is equivalent to 26. And now here whenever you see these values, mean 32, median 30 and mode 26, then you will understand that mode value is less than median value, which is again less than mean value, and that's why this would be the positively skewed distribution. Because in the positively skewed distribution, the value of mean is greater than median and the value of median is greater than mode. But in negatively skewed distribution, exactly opposite occurs. The value of mean is less than median, the value of median is less than mode. Okay, that's why your correct answer over here should be 1. And mesokurtic and platykurtic distributions are the types of kurtosis, and that I am going to tell you in the next part of this video. Okay. If the data are skewed, which option of central tendency measure is the most unreliable indicator? So whenever the data is skewed, I mean to say whenever the data distribution is asymmetrical, then in that situation which measure of central tendency is unreliable indicator? So whether mean is unreliable indicator or median or mode, because range is not a measure of central tendency, this is the measure of dispersion. Okay. So there are only 3 measures of central tendency, and those are mean, median and mode. So students, now let us see the definition of skewness. What is the definition of skewness? So skewness is measure of asymmetry of probability distribution of real valued random variable about its mean. Okay, and that's why the mean value will get affected whenever the data is skewed, and that's why in this situation mean will be unreliable indicator. Okay, and that's why your correct answer should be 1, that is mean. Okay. Now next is a distribution with a kurtosis which is greater than 3 is known as. Now there is a distribution and which has a kurtosis value which is greater than 3, then what kind of distribution it would be? Whether it would be platykurtic, mesokurtic, leptokurtic or excess kurtosis. So students, as we have seen skewness, so like skewness there is a kurtosis, but kurtosis exactly tells you how long the data distribution at the tail point and at the peak point. So for example, there is a graph and there is a curve. So kurtosis means what? How data is distributed towards the tail part and towards the peak part. Okay, so whenever there is a more data which is distributed to the tail part, then obviously this curve will be having more tail, and whenever there is more data distributed at the peak part, then it means that there is more peak. Okay, all of you getting? And this is nothing but the kurtosis. I mean to say the measurement of this kind of thing is called as kurtosis. Okay. Now students, let us see the different types of kurtosis. So platykurtic, mesokurtic, leptokurtic and excess kurtosis, these are the common types of kurtosis. Okay. Now whenever there is platykurtic data distribution, then in that situation the kurtosis value is negative, and here the tails are thin. Okay, so these tails will be thin than the normal distribution. And whenever there is a mesokurtic distribution, then in that case the value of kurtosis will be equal to 3. Okay. And whenever there is leptokurtic distribution, then in that situation the value of kurtosis will be greater than 3. Okay, more than 3. And leptokurtic distribution is the kind of distribution in which basically the peak has a pointer and the tails are fatter, okay, than a normal distribution, not thinner. And whenever there is excess kurtosis, then in this situation tailedness of distribution is relatable to normal distribution. Okay, and again the mesokurtic distribution is again very relatable to the normal distribution. Okay, and that's why your correct answer for this question should be 3, leptokurtic, because here the kurtosis has the value which is greater than 3, that is more than 3. Okay, that's why your correct answer should be 3. Which of the following distributions has a higher kurtosis? So here they have given certain names of distribution, that is data distribution, and which of the these distributions has a higher kurtosis, I mean to say has a higher value of kurtosis. So whether it is normal distribution, whether it is t distribution, whether it is uniform distribution, whether it is a chi-square distribution. So students, wherever there is uniform distribution which has the kurtosis value which is equivalent to 1.8, whenever there is normal distribution the kurtosis value is equal to 3. Okay, whenever there is t distribution which has kurtosis which is greater than in normal distribution, which is basically you can say more than 3, and whenever there is chi-square distribution then it has the highest value of kurtosis, and that's why your correct answer should be 4. Okay, because chi-square distribution has the highest value of kurtosis. Okay, fine. So students, thank you for watching this session. I hope all of you understood everything whatever I have explained to you. So but still if you have any doubts you can ask me in the comment box of this video. Okay.